Hello, boys and girls. We are doing the Unit 6 practice test in Math 1, counting and probability. Let's see if I can do this in like 10 minutes and keep it under the wire for YouTube. Without a calculator, okay, what I just mean by this is you're going to say this for combinations. That's 23 factorial all over, and then you subtract the 2. 23 minus 7 is 16 factorial. And then for combinations, you repeat 7 factorial. Learn that simple formula. So that is the same as then 23 times 22 times 21 times 20, all the way down to where we stop it at 16. So that's 19, 18, 17, and then the 16 factorial chops off with the 16 factorial. So that cancels, and those are gone. So what is this whole thing then? When it's 7 factorial, like that. Okay, so then I just start to cancel. And don't get too psyched out. 6 times 3 makes 18, so the 18 is gone. All right? 7 cancels with the 21, and I'm going to put a 3 out front. Okay? I've got a 5 in there. What can cancel with a 5? How about 20? I cancel the 20, I cancel the 5, and that gives me a 4. I'm going to sneak that 4 in right there. Oh my goodness, I can cancel that 4 with that 4. And then finally, the 2 cancels with the 22, and I get 11. All right? So that's where you could stop. You just say it's 3 times 23 times 19 times 11 times 17. You don't need to multiply it all out. All right? So same thing, only slightly different. This is going to be 10 factorial all over, then 10 minus 3 factorial. When it's passwords, you have more of them. I do not divide by anything else. So what is that? That's going to be just then 10 times 9 times 8. That's equal to 720. All right? 7 factorial is just 7 times 6, like it was up there. 5, 4, 3, 2, 1. Okay? You could grind that out, but mostly I just want you to show how to find. Show how to find without a calculator, and that's what I do. I'd multiply them. How many different ways can 8 coins be arranged into 4 heads and 4 tails? That is 8C4, okay? I can do this on a calculator. Super easy way I like using is Pascal's triangle, and that would be row 8. Go down to row 8 right here and go 0, 1, 2, 3, 4, and that is 70. So that would be my answer. And how many different ways can a coin be tossed 14 times and land 11 heads or more? Again, Pascal's triangle is often awesome for the 11 or more, because I go to 11, then I go beyond 11. So here's 14, okay? So I can go 0, 1, 2, 3, 4, but it's easier to count also from 14 backwards. So this is 14 out of 14, 13, 12, 11. So there's 11 or more, means I'm adding up all of these, okay? So I would do 14C11 plus 14C12 plus 13 and 14, and I'll get those numbers. So what is that? That's 1 plus 14 plus 91 plus 364. 1 plus 14 plus 91 plus 364. 1. Okay, I'll let you do the math there. I want to go fast. The math team went to the regionals. There were 13 teams. How many ways could the top 5 teams be ranked? Order is important. 13P5, okay? How many different ways, different groups, can the 5 teams be chosen to take the first round test? This is just a group of 5 out of 13. That's 13C5, all right? So just going quickly here, I would do math, and I go to probability, and then I'll do, I would do right here 13C5 and then 13P5, all right? So again, I'll let you do that on your calculator to find the answer. How many 6-letter passwords can be made rearranging the letters, all the letters of miscounted? Okay, you must use each letter once, and they cannot repeat. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So that's basically 10 P6, 10 letters to make my password, choosing them 6 at a time. Okay, so again, use the calculator, find that answer. You could also do it as 10 times 9 times 8, fill in the blank method. It's awesome if you need to, because that'll work. How many choices do you have for the first, and then second, third, fourth, fifth, sixth? Your choices go down. You use all the letters, and they can repeat. Well, that's just 10 times 10, 6 times. That's 10 to the 6th. That's equal to 1 with 6 zeros. I believe that is 1 million passwords. Next one then. What is the probability of tossing 12 coins and finding them showing 5 heads? Well, probability is the things we're interested in over the total. Well, if you go to Pascal's triangle and you do 12th row out to 5, or do 12C5, 12th row, 0, 1, 2, 3, 4, 5, that's 792. 792 out of a total of 2 to the 12th power, okay? So that's going to be 792 over, I think it is 4,096, but I'll let you verify that. But I know that is the correct answer. It's always NCR over 2 to the n, a handy little formula to know for probability of binomial things. Suppose the chance of rain in any one day of a 4-day week is 0.38. What is the chance that all 4 days have rain? You just multiply that times itself 4 times. Try that on your calculator, all right? Using the above information, design a simulation, sorry about the typo, to determine the probability that you have 3 or more days out of 4 have rain. Okay, my simulation, step 1 is I'm going to say rand int, it's a percentage problem, so I'm going to do 1, 100. If it's not given to me as a percentage, like I get 3 out of every 7 days of rain, I would do 1, 7, and then I'd choose the numbers 1, 2, and 3 to equal rain, because that's 3/7. But it's not, so I don't. And then I'm going to say step 2 is 1 through 38 equals rain, and then 39 through 100 is no rain. Okay, so then I'm going to get 3 or more out of 4 days, so get 4 random numbers, 1, 2, 3, 4, and you say if 3 plus are rain, then I'm going to say, oh, that's a sad face, all right? And then keep a tally. So you can just show me how you're doing this. Again, I'm going kind of more quickly. You can flesh in this. But if I got random numbers, I'm not even going to do it. But suppose I had 13, and then I had 7, and then I had 81 and 97. What would that mean? That would mean that these are rainy days, and that is 2 minus. I need to have 3 or more days have rain, so that's a check mark right there. So this equals, because it's not 3 or more days of rain. Then as many trials as time or money allow. Maybe 100. All right. So if I've got a bag of marbles that's got 10 white marbles and 5 black ones, with the probability that I get 4 marbles at once. So P4 is going to be equal to, well, that's a total of 15. So that's 10 out of 15 times 9 out of 14 when I have that marble in my hand, 8 out of 13, and 7 out of 12. choosing 4 at once is no different than picking them one at a time and putting them in your hand and then looking. All right, so here I do some fancy canceling. 10 over 15 is the same as 2/3. And again, I can do some canceling, but I think I'm worried about time on the calculator, on the movie running out. So I would just multiply the tops, multiply the bottoms, math into fraction. That'll give me that probability. Suppose there's a choice of 7 English classes, 5 art, and 4 history. How many different schedules could you make? That's just 7 times 5 times 4. That's 7 times 20, which is 140. All right? Well, the 40th row of Pascal's triangle begins this. This is 40C0, because that means 0 heads. There's only one way to have 0 heads. That's all tails. 40C1, 40C2. If you count like this, you're not going to go wrong, because that is 40C3 and 40C4. You look those up, see what they are. Okay? Finally, which of the following are binomial experiments? If not, say why they are not. Tossing 10 coins at once, recording the number of heads and tails. That's yes, because you need 3 things. You need there to be a finite number of trials. You need to have only 2 outcomes possible, heads or tails, black or white, marbles or something like that. But then it's also, they cannot be dependent. They must be independent. They cannot influence each other like choosing out of a bag of marbles. So rock, paper, scissors, nope, that's 3. Rolling dice, 2 dice, there's a lot more than 2 outcomes, so that's not. Recording the number of boys and girls in each of the Frosch art rotations. That is not, because you don't know how many students are in the Frosch art rotations. And yeah, it's just a poorly worded question. We are going to just throw that one out for several reasons. But tossing a coin until 3 heads in a row turn up and recording how many tosses it took you to get there, that is not necessarily finite. So that is also no good. Okay? So that was a breeze through. Hopefully that is helpful.